Good morning, Professor. Sir, பண்ணுங்க sir, பண்ணுங்க. Hi. You are in mute.
Now?
Yeah. Very glad to see you. Thank you so much for all the guidance you gave us for getting the approval from IFIP and all the things which has happened.
Just sharing experience and you know, I have Indian student in Paris.
Oh yeah,
and
okay.
They attend international master in EPITA.
Okay.
Engineering school.
Okay.
And it is over 10 years now.
Okay.
They come also from Chennai.
We are also in Chennai. We will wait for the participants to join, Mom.
Yes, and we prepared the presentation with Dominique Verdejo, who is in charge of a new working group in IFIP. And maybe I try to share my screen to see. Mettre in play. Dominique, tu veux essayer la présentation globale ou pas?
Alors, cette présentation, hello, Priyadarshini.
Hello, sir. Hello, Professor.
Okay, I will start with that and after you switch to yours, okay?
Voilà, moi je pourrais très simplement partager, on va juste faire un test de partage. Voilà, il faudrait, à ce moment-là, il faudra que tu me donnes la main en arrêtant le partage de ton côté. Voilà, et à ce moment-là, je reprendrai le partage et je partagerai donc ma fenêtre qui se situe là, il faut toutes les afficher, qui est là, voilà. Voilà. Et là, je passerai un diaporama.
Go to first slide.
Je reprendrai à partir d'ici.
Go to first slide.
First slide?
Ok. Donc, je partage mon truc et après tu reprends?
Je reprendrai à partir d'ici, sur mon premier slide.
Ok, donc tu
voilà.
arrêtes de partager.
J'arrête le partage. Voilà, the floor is yours, Professor.
Attends, on attend les participants.
We are waiting for the participants to join. We will start in a few minutes.
Yes. It's okay for you. Can I call you Priya?
Yeah, sure.
It's easier for me.
Yeah.
Yes. Okay. And let me know how many participants you have.
Actually, we are expecting around 50. They are joining. Actually, paper presentation is also going on in parallel. So after that, they will join this link.
Okay. Then I will explain very shortly technical committee we have, because we have new technical committee. And the same, everything is moving, you know, is technology. Then, of course, your students are invited to join because we need a new generation coming.
Yeah, obviously.
Yeah. Then I went shortly through the paper's title, not abstract because I had no access. And this is very various topics, and that's very good.
Okay, thank you.
And what you teach?
My research area is computer vision.
Computer vision.
Yeah, I did my research in acoustic image processing, where I would identify objects in underwater objects. Yeah, I have developed an algorithm for detecting the objects underwater. The underwater images, yeah, underwater images
in the water because you have waves, and then this is a sort of noise.
Yeah.
For detecting.
So the images what we have used for my what I have used for my research is obtained from sonar. A specific sonar like side scan sonar was used for acquiring the images. We use the side scan sonar for getting the images. I pre-processed the image and I came up with an algorithm for object detection.
Very good. Then you can detect the pollution in the ocean.
Yeah.
Yes, this is a lot of things to do. It's including industrial robots participating in production, in detecting the pieces for a production chain, and so on. A lot of applications.
Yeah.
Then your conference is IFIP event since it is third year.
Pardon? I don't get you, ma'am.
It is third year that your conference is IFIP event.
Yeah, it is IFIP event.
Yes, very good.
Yeah.
Very good. And you plan to publish Springer book, of course?
Yes.
It's already?
Yeah, after getting your permission, we have approached Springer and they have also given permission for us to publish the paper in Springer proceedings.
Yes, very good. Then you applied for to Springer already?
Yeah, we have applied.
Yes, because they changed the person. This is Christina something who is in charge, Christina Rice, who is in charge of this.
Okay.
Then I will send you her contact.
Sure,
because it was Miriam before, and now they changed it to Christina.
Okay. Actually, I got mail from.
What you have? What you have as contact?
I got it from Ronan Nugget.
Yes.
Nugget.
He's a boss.
Yeah. I got mail from that. From
okay, good. Good.
Actually, now after this conference, we have to prepare the proceedings. Yes. And when we submit, we will be getting the volume number, right? This is our understanding.
And you can also, if you wish, of course, you can, as I'm doing in another working group, ask the student for extended papers.
Oh, okay.
If you wish.
Okay.
Maybe, because the papers, usually the papers on the conference are shorter.
Yeah.
And if you wish to have more, you can try these extended papers.
No? For sure.
Yeah. Anyway, it's published in India, but it's an Indian person in charge of.
Oh, okay.
You will see.
What is which in you're telling about the extended paper where it will be published? I didn't get your.
I think it's produced in India.
Okay.
And publishing process is managed by the Indian team.
Oh, sure. Okay.
I don't remember the name. It's it's always too complex for me.
Okay. Yeah.
Okay. But I had the message for my previous book just published on AI for knowledge management, energy and sustainability.
Okay.
Then you can also participate in the other groups.
Sure.
Of course.
Sure.
Yeah.
We will. Jansi?
Yes, Priya.
Jansi, shall we start? We have only 12 participants.
Yeah,
Shall we wait or shall we start, Jansi?
we can wait for another 5 minutes if it's okay from
Professors,
Professor.
Professor Eunika and Professor Dominique.
Yes, it's okay, but because you said 1:30 for you, I'm there. Okay, it's no problem. No, it's not a problem.
Okay.
And for discussion, how we do for discussion? Because they ask a question by chat, or who manage? The Yancy who manage? Who manage this? Or you?
They can ask in chat, and also
Discussion,
they can, discussion can happen both via chat and or they can unmute and they can ask you the question directly.
Okay. And you manage this? You manage the questions? And I have to look the chat.
No, I will ask you. I'll be active and I will interact with you.
Okay.
If there are any questions in the chat, immediately I will let you know.
Maybe for the next, you are for.
Jansi, we will start, Jansi. Anyway,
Okay.
it is streaming in YouTube, so we can get the insights in the YouTube also. Okay. Professors, shall we start?
Yes.
Okay.
Okay. Good afternoon.
And
Good afternoon, everyone present here. Myself, Dr. Jansi Rani, Associate Professor from Computer Science, here to anchor the event. We welcome back all the audience and the participants for the second keynote address of the International Conference on Computational Intelligence and Data Science. We would like to invite you again for the second keynote address on what AI for global security. Now I request the conference chair, Dr. Priyadarshini, to introduce our keynote speakers.
Thank you, Jansi. Good afternoon to all. It's my pleasure in inviting the keynote speakers for the session. Today we have Professor Eunika Mercier-Laurent and Professor Dominique Verdejo with us to share their insights on the topic, what AI for global security. Eunika is the Professor of Artificial Intelligence and Knowledge Co-Innovation EPITA. After completing her electronic engineering, she did her doctorate in computer science from Paris University. She has been associated with the Global Innovation Strategy since 1996, which is an international network for knowledge management, innovation, and AI specialists. She is also associated with 3D Innovation, which is an international association for global innovation since 2007. She is a chair in IFIP TC12 Artificial Intelligence, member of the Management Board, Knowledge for Innovation EU, expert for EU programs, and author of more than 100 scientific articles and books. Her research interest includes AI for innovation ecosystems, knowledge management, and solving complex problems, eco-design, impacts of AI, and AI for sustainability. She is also part of the editorial board of Springer IFIP AICT. And she is a reviewer for several refereed journals such as Springer, Elsevier, and so on. She has acted as PC member and has given keynote talks in several conferences. Welcome you, ma'am.
thank you very much, Priya, and welcome to all participants.
I will also introduce Professor Dominique. Today in this session, we also have Professor Dominique Verdejo. He is an ISO certified lead auditor, GDPR compliance auditor, and external GPO. He has over 20 years of experience in IT architecture, security system integration and consulting, including cyber security, video surveillance, identity access management, with a constant interest for innovation, design thinking, and AI applications. After spending 15 years in the software industry as an R&D engineer, a product and a project manager, he created his first video surveillance system as a service startup and launched a security consulting activity in 2000. He has a master's in computer science and artificial intelligence from University of Paris and a master's in enterprise security from the National Institute for Security and Justice in Paris. He is a proud member of the Paris government's cybersecurity awareness project. He is also chair in IFIP TC12 Working Group 12.13. His research focuses on AI and security. We are happy to have Professor Eunika and Professor Verdejo here with us for ICC Ideas 2022 as a keynote speakers. Thank you for accepting, and over to you, ma'am.
Thank you, you're welcome. Then what AI for global security? But I will start with IFIP because we, 2 years ago, we celebrated 60 years of IFIP. IFIP was created with UNESCO in partnership with UNESCO, and now we have reinforced collaboration with UNESCO, especially in the field of ethics. Then we have 14 technical committee in technical assembly, and you have the chairs here. Of course, you can check the IFIP Mine website for more information. But I think if you are interested in some of these technical committee, you are free to join. Then first is on foundation of computer science. Second, software theory and practice, education, which is very important today, information technology application, communication systems, TC7 system modeling and optimization, TC8 information systems in general, TC9 ICT and society, TC10 computer system technology, TC11 security and privacy protection in information processing, TC12 my TC, which is artificial intelligence, and 13 is about human computer interaction, and the last created 3 years ago, it's entertainment computing. Of course, there is many interaction between all these technical committee, which is managed by technical assembly. Now, in TC12, TC12 in fact was created in 1981, which is an old technical committee. You have a link to the website. And currently in TC12, we have 13 working groups. The first is on knowledge representation and reasoning. You probably know Ulrich Furbach, which was my predecessor, and he's still involved in this group. Second is on machine learning and data mining. Third is on intelligent agent. Fourth is on semantic web. Unfortunately, it was closed because of unavailability of the person who chaired this group. But I would really like to run this group again. Then if you have the candidates among you, you are welcome. 5 is artificial intelligence application. They run the conference AI. It is mainly in Greece, this conference, but with international participation. 6 is knowledge management that I manage. I chair 2 for the moment. Working group 7 is on social networking, semantics, and collective intelligence. 8 was also closed, but we absolutely need this, and we are preparing the new group to replace this on health, artificial intelligence for health. 9 is about computational intelligence. 10 artificial intelligence and cognitive science. And 11 created 2 years ago, it's artificial intelligence for energy and sustainability. Recently created 12 AI governance, and the last that will be presented by Dominique, it's AI for global security, just approved by technical assembly. And of course, we have a collaboration between all these working group and also other technical committee, because AI is everywhere now. Then today, this slide represents the patrimony of what we have, what we produced since the official birth of AI. And we have a lot of techniques today. And the people focus only on deep learning here, while machine learning is, as science was founded in 1970, and we have a lot of other possibilities and to use and to combine the techniques of symbolic machine learning with connectionist machine learning. And already in 2000, Richard Michalski, who was the founding father of machine learning, launched a conference in Portugal, Guimarães, on multi-strategy machine learning. And multi-strategy machine learning is sort of toolbox. Then you have all these algorithms that you can use, and they are available. And of course, you can combine for better efficiency. As technology, we have something which is not very known, which is constraint programming. Constraint programming is very useful for the combinatory problems with constraints, such as scheduling, planning, manufacturing, and it is much more better to use constraint programming than try to do it with machine learning, which is not effective for this kind of problems. And we have multi-agent systems which integrate now many various algorithms. It's also a toolbox, collaborating toolbox, then we have to our disposal to use in function of the problem to solve. And this is a part of knowledge. Then the people since now over 15 years, 15 maybe more, developed the various knowledge model. One of them is ontology. Maybe Dominique will say something about that, but it is a common used model now for knowledge management, collaborating with data analysis. Then we can cross the result from the database using ontology. What more? Not knowledge processing, of course, but we have also natural language processing. And at this stage, we have to make a distinction between knowledge, natural language processing and natural language understanding. For example, today we use a lot of natural language processing, but without understanding, without deep understanding. But it is really very important for assistant, and especially individual assistant working for me, for chatbot, for effective chatbot, especially in industry and in the other fields. Speech recognition, it's working very well because we have now multi-modal interfaces. Image processing, you have your professor specialized in image processing, signal processing, knowledge processing, etc. In terms of hardware, we have AI architecture. Now, researchers are working also on neural machines and, of course, robot, IoTs, drone, etc. Then we have all these to our disposal, and please use all this technique and use it to elaborate the smart and green solution. Just a little bit about third type of AI, because it came through marketing, mainly through marketing. And the main motivation was to sell more and quicker. That's why Amazon was among the first who triggered this third type of AI. Unfortunately, they use only deep learning and analytics in the first time, and deep learning on navigation data and build what they call client experience, which in fact is not the client experience, it's just the tracking of the client navigation. And for example, if I accidentally go to click to the website I'm not interested, and after 30 seconds I quit this website, I'm registered as interested in this field, which is not my experience. Next part is intelligent assistant, and of course we have, you probably use the intelligent assistant. My dream is to have really intelligent assistant for me, working with me, learning from me, and not just traditional for everybody. Then we have, there is still the progress to do in this field. Of course, robot, drones, and IoT and autonomous system, the base for this was built long time ago, and now it becomes more popular because of power of machines. And we still have a lot of needs and real challenge, because we have to face the complex problems such as climate change that requires not only big data, because big data is the opposite of environmental, generate a huge environmental impact. Then we need probably alternative solution to solve all, to address all these complex problems. And today we have AI is embedded in a decision support system, in many applications. We have the drones, as you have here on the picture. It's 100 kilometers north from my place. It's a higher Viaduc de Milo. And this guy here is testing, uses the drone to for detecting of the faults in the viaduct. Then it can be used for thermal diagnosis of building also. Now there is many application of what we call building intelligent management. It's used for measurement of cereal surfaces, to evaluate the fertilizer we need, for inspection of power lines, and many other possibilities. Becomes very, very common today. And we have a future factory which implement Industry 4.0. And the characteristic here is that this system collaborate with human. They were built not to replace the human, but to help human in their work. And on the left, you have the image of Schneider Electric factory, future factory. And on the right, it is a Safran cobots, also in France. You probably have Schneider Electric in India too. Then we have a lot of AI in Industry 4.0, switching to Industry 5.0 now. Then we have robots, Internet of Things, simulation with digital twins, and cybersecurity, which is a part of a global security of the system. Cloud computing, which requires security too. Additive manufacturing with 3D printing and coming 4D printing, augmented reality and virtual reality. It's related to economy with growth and job, to leadership of the company who use this. It requires a huge energy to work, policy to make it run, and to create the politics to facilitate this kind of development. It requires a lot of human knowledge and experience. and generate an impact on environment. As we can see, there is a lot of needs for security here. And as I said, we have still the complex problem to solve. For example, as I mentioned before, effective assistant able to learn with its user. Optimization everywhere. We need to optimize the use of water. We need to optimize the use of energy, the transportation in the city. And of course, we try to optimize everything we do in design, in industry, in the other fields, and especially in health industry, etc. Eco-design, it is something that we have to, it has to become a habit to work on eco-design. It should be, eco aspect should be integrated into design, and especially in IT, because we produce it a lot. IT produce a lot of waste in terms of devices and generating of heat in data center. In terms of devices, the release as the software change often and takes more and more places, we have to update our device to run the new software. And it's a vicious circle because we update and throw it up. And the solution is probably eco-design, and maybe as build the devices as Lego boxes, then instead of throwing out the whole device, we can just change the pieces that should be changed and keep the device. As for example, Xiaomi, which design the smartphones, they already use this kind of eco-design. Recycling, it's good, but recycling uses the energy, and we have to be careful on recycling. It is better to maybe to smart buying. It's better than buying and throwing up for recycling. And especially in technology, it's extremely important to do that. And in terms of energy, on this picture here, you have data center in Scandinavia. This data center, as you know, generate a huge energy, and this energy generate the heat for the environment and contributes to melting ice. And now they try to introduce the circular energy to use this heat from data center to heat the houses, to heat the schools, and hotels, and so on. In terms of software, I would like, it's already the trend to build the greener software. At this stage, we can use the principle of old principle elaborated by one of the founding fathers of AI, Alan Newell. He introduced the knowledge level. And knowledge level is something above component level, network level, and it is consists at conceptual modeling of the fields, given fields you work on. And the main principle for this was genericity, reusability, and modularity. And this principle should be applied into the software generation or design. Global security, I leave this to Dominique because he's the expert in that, but this is a real complex problem to solve, because we have not only one, but the security is a complex problem composed of many things that should be considered in globality, that with holistic approach. And one also point that it's coming, and it is very interesting, will be very useful in the future, is human spare pieces, combining the electronics with programming. And all these problems requires hybrid system, not only big data and machine learning. Then combination of all that apply at all that can help us to build the greener and smart software. At this stage, we have to think about the warning and risk. But today, because it's a trendy, many people use the same. When I ask to my students, I have this problem, how you suggest to solve this? And they answer big data and machine learning. I said, no, you have to think, you have to use your brain to analyze the problem first and then apply the right technique. And this is a risk to use the techniques that there is not the best for solving the given problem. Then I advise the student to be curious and to try to know the other techniques and try to think how to find the best and greenest solution. Of course, we have to be aware of the bugs of autonomous system, because we never can test everything in each situation. And especially when we have a fully autonomous system and people are confident. For example, you probably have heard about the crash of the plane Rio-Paris. It crashed because of missing data. The data was, the detector, part of the detector was frozen, and with no data, automated pilot was not able to work. And the human who took the lead of managing the plane was not experienced, lacked of experience, and it led to a crash. And we have to think also about polluted data. And Dominique will explain this problem, how to remove or prevent the pollution of data that serve to generate the models. And next, it's a weak mastering of machine learning programs. Sometimes program was conceived for doing something beneficial, and it can change, it can develop a destructive method to achieving another goal. And the next point is about bad usages. For example, we have a lot of AI today in autonomous weapon. This is a link to a video maybe you have heard about the miniature drones equipped with a face recognition system and with a small explosive able to recognize the face and damage the brain. Imagine if the system make an error. And another point is about switching off the brain, what I call switching off the brain. Today application has have a huge cognitive impact. Then we have a lot of application advising us, suggesting us to buy this, to go this way, to go to this restaurant, while we have the brain. and we need to use our brain. If we don't use, our brain will be atrophied, and instead of the brain, you will have a smartphone, because you have all this in this kind of application. Then at this stage, we have to be aware about what is really useful for human, and what we can do it with our brain. And on this drawing here, which is described in my book, Innovation Biosphere, I mention 8 impacts, of course, economic, social and societal, cultural, politics, and environmental. And think about all impact you generate, and this impact can be evaluated before doing, and it is sort of eco-design. Think about evaluating the impact before doing. And my opinion on fourth generation, which is coming to improve what we do with big data and machine learning, is expressed on this drawing. And we have still multi-source, heterogeneous, and unstructured data that we process with data-driven machine learning, building the models and then searching, that we integrate with knowledge models and human expertise to get explainable and robust decision support system. Explainability is something very important in today's system, because in many cases, human needs explanation why I got these results, and how to manage the initial data to get the better results. And as you know, this is a big problem of we try to solve in ethics. Then data are also polluted, and they are not updated. It's nobody who is in charge of cleaning of the data from the web, for example. Then we have a lot of outdated data, and it's still they are still here and still use the space in data center and web. And from this, we can propose the knowledge-based services for business. Another point is this one, how to combine when we collect the data. We can use this collection guided by the knowledge models on one side, and on the other side by ethical principles to get the good quality of data of good quality, and in the same time responsible AI. Then some perspective on AI. I think then we are moving from data science, because data science is something very trendy. Many companies and many students are excited with data science. When I ask my student what you want to be in the future, they answer data scientist. And nobody is talking about knowledge scientist. And tomorrow we'll have the need maybe in next years for knowledge scientists. We have to think about reducing IT waste. As I mentioned before, we produce a lot of waste with IT and the other field, of course, which contributed to climate change and global pollution. Then we can reduce it with embedded eco-design and thinking about this modularity, reusability, and genericity. which was the principle of the first generation of machine learning. My proposal is to make data slimming, because we have data obesity, but nobody is talking about data slimming. And this is really very important for environment. And we don't need the huge amount of data, we need the relevant data. And the purpose is here, how to select the relevant data. And as I mentioned, circular energy to reuse the heat from data center, for example, to heat the houses, etc. We will also use this example by analogy to for circular knowledge. What it means? It means that we have a lot of knowledge around, and we try to share this knowledge, but it's not sufficiently done. Then we need to reuse the past experiences. The people who worked from the beginning of AI, they invented many things. They have a lot of experience. We cannot scratch them and use the things from scratch, but think about combining all this experience and build on previous experience. And I give these 2 links to the books with my articles on. The first, it's this one, produced by a working group AI for Knowledge Management. And the article is, can AI effectively help in sustainable development? And the second is about, it's coming, it's already available on the web, Artificial Intelligence for Knowledge Management, Energy and Sustainability, with my article on digital transformation, how we can use AI for smart and green digital transformation. And of course, in the book edited, published by for 60th anniversary of IFIP, this is my article on future of AI and AI for future. And if you are interested, it's available on ResearchGate. Why we talk about global security? Because in all system I shown before, we need the security, and it is interlinked complex problem. And all fields are concerned. And today we have IT everywhere, and also AI in health, in food, in water, energy, transportation, and we need the security for all these things. And we have a lot of threats and fake. And we have also, we need AI to distinguish the good and bad, and to detect the fakes. We have to face the terrorism with early detection of low noise or low signals, and with war, as we have in Ukraine, this war of security too. The security is smart city because everything is connected, and everything here can be hacked, and we have to prevent this. And Dominique will explain how it can be, how we can prevent, and what the methods can be used to this. And I will finish with security in United Nations, in 17 United Nations sustainable goals, because we have, we need to apply the security for everything, for quite all goals. Then sustainable city and communities, climate change, water life, life on land, peace and justice is very difficult topic. Poverty and zero hunger, it's also worth of considering. Good health and well-being, quality education, access to education, clean water and sanitation, and industry and innovation. Then we have security in many of these goals. And I stop here and pass the floor to Dominique. And we will have, as you wish, we can have a discussion after two presentation or now. Yancy or Priya, how you manage this?
Priya?
Continue. Go, Dominique.
Okay, so let's assume we move on from here. Well, thank you very much, Eunika. This enlightening presentation is, I think, the best introduction we could have for my presentation about cloud security. I have pointed out two particular information in your presentation in the very last slides, which are to me, representative, very representative of the global context that we have. You talked about the data slimming, and the data slimming. It's pretty important to note that it's the major point that led recently to the creation of the General Data Protection Regulation in Europe. The fact that the big US IT companies like Amazon, Facebook, were gathering and collecting so much information that is not really useful is to some extent shocking and must be regulated. Well, this is the case now. There should be data slimming in the information collected, and this is for the privacy of the users, which is, of course, one component of the global security. And second point that you made, which looks very important to me, is, of course, the fact that AI and security have one thing in common. Well, first, of course, AI is an excellent tool for security. But two, and more importantly, AI, just like security, are cross-components over a very wide number of domains, and particularly domains for security that I will now present. So, in the aims of the TC 12.13, which is the working group 13 that we just created for the TC 12, Technical Committee 12 AI from IFIP, we have identified the need to study particularly the different faces of security, and we have identified 4 domains, essential domains, where security is really needed. What we see here is that the first domain is cyber. We talk a lot, of course, about cybersecurity, and we see cybersecurity becoming a real issue at the moment in the geostrategic context and the war in Ukraine that you were mentioning. Of course, as IT is everywhere, security of IT, which is cybersecurity, is everywhere. And we have to protect our systems, but not only our systems, we have to protect objects. And we know that the technology is now very pervasive, and it enters everywhere in our lives, in our homes, in our enterprises, in our collectivities. Technology is everywhere, and technology may be a vulnerability if it's not protected. And so we have identified cybersecurity of really the most important part, since cybersecurity is also security of the systems, security of the security systems. So there's some kind of recursive speech here about the security. We have to protect everything, including the security systems, which are also IT systems. And the second domain is physical security, where we have to protect people and assets against intrusions, destruction, theft. For instance, you can cite video surveillance or access control, which are disciplines of physical security. The third domain is economical security. And there again, you have to protect citizens, you have to protect individuals and companies against fraud, theft, or competitive intelligence, which is another form of intellectual property theft most of the time. Last but not least, we see that security is also security on a psychological level. And we've seen, notably with the rise of social networks, the fact that people are now connected, very connected through the smartphones, through the computer, and this connection can lead to influence. This has been the case, for instance, in some very important elections in major countries. And also, unfortunately, the social networks can be an excellent vector for radicalization, leading a close contact between major terrorist groups and people located in their target countries. So we see here that security is really a global system per se, or a global way of thinking, and that it has to be considered as a holistic problem and solved with holistic systems in mind. So what are we expecting from the work group 13 in TC12, security for AI? We are, of course, expecting high quality scientific studies and papers to be produced. And I think this is the best we can expect and hope for the global scientific community. So we hope that the gathering different domain experts, different enterprises, different end users, collectivities from different countries will help that process. But isn't it the general purpose of scientific research? We hope that thanks to this global thinking about security, we will produce applications, results, and notably contribute to enhance the protection and the surveillance of people and infrastructure, thanks to the drones you were mentioning, Eunika. We hope that we can improve cybersecurity through all the different components of cybersecurity. And we hope that in the end we will better fight against crime and terrorism. And as you said, of course, this is something that has to be done by including processes, policies, and technology in a global design. So we have identified among the very numerous techniques and technologies of AI, we have identified 4 different categories, I would say, categories that can be using symbolic or neuromimetic techniques. The first category of technologies is bound to automated reasoning. The automated reasoning is based on these technologies that can simulate to some extent human reasoning. It includes, of course, the latest developments in deep learning, but also the multi-agent technologies and the scheduling and constraint-based technologies previously mentioned. It also includes expert systems and case-based reasoning. We have identified previously also in the presentation knowledge management as a very important asset. Knowledge management and the knowledge-based services have to be investigated very thoroughly now, since knowledge, just like data, is growing and needs to be managed. If we don't create systems to manage knowledge, just like we manage security, we will be facing a very large problem that we won't be able to transfer knowledge from one generation to another, and that is becoming an issue. The third area here of technology and techniques is the artificial perception and human-machine interface. And this is specifically based on techniques and technologies that have been developed in the past 15 years, I would say, and specifically about machine learning in terms of capturing, analyzing senses, giving the sense to the machine by artificial vision. We are now talking about artificial sensing. So there's a lot of progress made in that area that enables better communication between the machine and the human. And we're mentioning natural language processing and understanding, which is not the same, of course. But look, now the machine, take Alexa, for instance, from Amazon. These artificial intelligence perfectly understands the words that you say. I mean, at least from a perceptual point of view, the assistants from Apple, Amazon, Google are excellent pieces of technology. So now we have to work on the language understanding, but at least for the language perceptual part, this is absolutely excellent. Look in another field like artificial vision, and Priya, our host, is an expert of artificial vision. She will understand perfectly. What happened since 2015 in machine learning and deep learning is absolutely outstanding. And we can say that today a computer has a better vision than a human. And since those techniques can be applied to very different visual signals, like radar, like sonar, like thermal vision, it goes beyond the senses of humanity. It already overtakes us in this domain of vision and perception. The fourth list of technologies is analytics. Well, analytics is mostly about data mining, as we previously mentioned, video analytics, which is a specific category of artificial vision, behavior analytics, very useful both in cybersecurity and physical security, like circulation control, for instance, and sentiment analysis. Again, the social networks can be used and must be looked at very cautiously, because they can be used for analyzing the sentiment of the people who use them, just as they can be used, unfortunately, to influence those people. So we see that AI for security, for global security in all these domains, and with all these techniques, can have a powerful impact. And conscious about that, we must not forget that there may be, as we said, subversive use of AI. So there's been a lot of consideration, notably in Europe, for misuse of AI and risk of AI. I'm mentioning here two initiatives. One is from the American NIST and the other from Europol, that deal with this problem of misuse and ethics AI. So I have abstracted here three, at least three, but there are many more, characteristics of this ethic AI for security. It should be lawful, it should be ethical, and it should be robust. So now I propose that we have a look at three typical examples of domains where security is enhanced by AI. The first on purpose is video analytics. Video analytics had two phases since it was born. It's the capacity of the machine to assist human in video surveillance. It's been out as a video filtering component in cameras since the year 2000 approximately. And we've seen very basic filtering made on video for detecting tailgating, wire crossing, as I mentioned on the slide, abandoned luggage, for counting people, for detecting movement and movement direction. This is very, very simple, very simple processing of image that was basically based on the MPEG algorithm and facilitated by the ASICs that are running into the cameras. So that's why the industry proposed them. And the idea was that the camera could do some kind of pre-processing on the image and help the operator of video surveillance or the alarm management system to detect behaviors and raise alarms. But since 2015, we have entered a second era of this video analytics, and this is due to the considerable computing power that we have gained with the GPUs, notably, that have allowed inferencing systems based on deep learning models to be run in real time over the video signals. and that are now achieving very, very interesting results, analyzing images in real time and detecting faces, people, objects, being able to label those detections and provide a very supportive help for video operators. And the best example of this enhanced video analytics brought by deep learning is face recognition. Face recognition has made a quantum leap. It was stalled up until these technologies arrived, and is now a very trendy application of biometrics. Face recognition works very well, and if we can abstract the difficulty of the data sets bias, we have a technology that is basically functioning on very large scale, for example, in China, and that's a very good example, a very good application of this video analytics progress. Beside video analytics, another example and another domain is the SOC, the Security Operations Center in cybersecurity, where we have different ways of improving the human-machine cooperation thanks to AI. So that's an excellent example. So if, for instance, the workflow operation is being facilitated by expert systems. The perception of the risk, the early signals, the early warnings about a risky situation due to an interesting behavior in the system, for instance, that could hardly be detected by tools and are very easily now detected by machine learning models. So both for known threats and unknown threats, AI has technology and techniques to provide to the SOC for enhancing the task of the SOC operators. The event correlation also is a very good example where AI can provide substantial support for human detection. So we see here an excellent example because we are in a control center. The control center is key to security operations in many domains. We have control centers for radar surveillance, we have control centers for drone surveillance, we have control centers for video surveillance, we have control centers for crisis management, control centers for cybersecurity. There are control centers in every domain of security, and what we can do for cybersecurity can be translated in other domains. Talking particularly about threat management and threat intel management, AI has a very interesting cross-domain opportunity. The last example of application of AI to security is in crisis management, and there we are facing with huge demands from the people. For instance, in an environmental crisis management, you have houses destroyed, cities destroyed, and not talking about war, obviously, but these massive destruction lead people to ask questions, and it's very difficult for the first responders to be efficient in calming down the population. So we see here a potential application. There is currently a trend in using AI to create bots that understand the people difficulties and are able to provide the first level of information to the people in difficulty. So we see AI here as a vector to facilitate the exchanges between the citizens and the protection agencies. And that's a very interesting application. So now from a more global point of view, I'm using here the architect that Eunika shared with us in the previous presentation, where we see that there is effectively an interesting convergence between a symbolic, I would say, human knowledge and more data-driven processes. And this integration has to be made in order to provide something that can be understandable, explainable, and this is leading to the knowledge-based services. So this was what Eunika explained to us, and if you have a look at the right part of the screen, you see that in notably the very important control center application I was mentioning previously, we have exactly this integration between information which is data-driven that flows from the sensors and machine learning and data-driven systems that are hosted mostly in the cloud, providing AI services and big data services, and the operators who are kept in the middle. Between those layers, there is a data transmission and a feedback transmission. And this is where the interface between the human operator and the AI systems is very important. So maintaining and optimizing these interface between the system and the human, we can create a very virtuous loop that enables AI to learn from operators and operators to be assisted by AI. So we keep in mind, of course, that the human in this architecture is maintained at the core. So there's no objective to replace the human operator, and it might be very dangerous. Think, for instance, about the surveillance of a nuclear plant. Who would be releasing a fully autonomous system for maintaining security of a nuclear plant? It would be a foolish move to do that. Human operators have to be maintained at the heart of security systems, but they have to be supported, assisted, enhanced, augmented by AI. As a conclusion to this presentation, I would like to make a specific point about identity management. As a security expert, I have witnessed that most of the security flows, notably in cybersecurity, but this is true also for all security domains, as we said, because IT is very pervasive and is now inside the security systems. So cybersecurity is priority number one. And in cybersecurity, we see a lot the identity theft being used and being an essential threat to the overall global security. So we have to pay particular attention to identity management. So this is my message here. The second message for conclusion is that we must always be in a preventive attitude and consider that security is not the cure to a plague that cannot be eradicated. It's the consequence of not having trained, educated, sensibilized enough. So we need to develop among users, citizens, collectivities, by education, by game, by communication. We need to develop a sense of security and global security. So I would like to end up this presentation reminding, unfortunately, as we say in cybersecurity, that the weak part of the chain in security and cybersecurity sits very often between the chair and the keyboard, which is us. So we have to keep in mind that security is not a state, it's a state of mind. Thank you very much. I will now release the floor, and if you have questions, I will be happy to answer them.
Participants, if you have any questions, you can raise so that the professors are ready to answer.
There's no security
Students.
issue in raising questions.
Any questions?
Everything was clear. Now they have to digest this.
Students?
And curious students.
If you have questions, please raise. Okay, so the participants don't have any question. So Professor Eunika, thank you so much for being a keynote speaker for our conference. I thank you for sharing the details on IFIP technical committees. We got insight to AI concepts and perspectives. Hope the participants would also have got rich information about AI in global security from you. Thank you for supporting us in every step we have taken in obtaining the approval from IFIP. Thanks so much.
Thank you for inviting us. And if you have the further question, please send us, I don't know, by email or as you wish, or send to your professor, and your professor will send to us.
Sure, I will forward the questions. And Professor Dominique. Professor Dominique Verdejo, thank you for gracing our conference with your presence and sharing your knowledge on what AI for global security. You explained the importance of AI for various applications in a very interesting way. And thank you so much.
You're very welcome. I was very happy to be back in India, even remotely. I worked intensively with India since 2010.
Oh, great.
And I'm looking forward to work again with you.
Sure. We are also looking forward for the offline conferences the next in the future.
Okay, thank you.
Okay. Thank you. Thank you so much.
Thank you. Goodbye.
Bye.
Bye.
Students, feedback link is shared. Please fill the feedback link. Please fill the feedback using the link.